This is the topic for AS level for the transformation of the functions, where we will find the real and the image, and due to these properties, which will be explained later on, that how the figures are being changed into their shapes. Since transformation is basically the change of the figure from one place to the other, so in this, we know that the real is going to be transferred to image. So this means that if real is x, y, image of this one would be x dash and y dash as p dash there. Now we are going to describe the different cases for this part. Y equal to f of x is the general graph for every function there. And we are now discussing this property that y equal to a f of x, where a is the constant number and f of x is the function there. So a is going to be multiplied outside the function a there. If we have to write down in the mathematical form for this function, then if p is xy is the real coordinate, then it will be changed to this form as x and a y there. This means that x coordinate is going to be retaining its position same, whereas y coordinate is going to be changed with the multiple of a there. So it is basically x, y will be changed to this point p dash x and a, y there. Suppose p is 1, 2, where a is equal to 2, then p dash will be equal to 1 and 4. If a is equal to 1 by 2, then the point 1, 2 will be changed to this as 1 and 1. And if a is equal to minus 1, then the point 1, 2 is going to be changed in the form of 1 and minus 2. So these are the three different cases which we are going to elaborate it here. So it means here y values are doubled. Here y value is again the double of this 2 into 1 by 2 is equal to 1, and here a is equal to minus 1. That is what a is minus 1 into 2 is minus 2. So it is basically, if we now draw it with the different figures, we see that it is basically, in other words, is known as we called stretching about y-axis, because y values are changed and they are doubled or half or whatever is the value of a is there. So it is basically the stretching of this pxy coordinate with the a value, and that is stretching about y-axis there. Suppose that we do it with the example there. Y is equal to f of x, and let's say that is equal to x square. If we draw the graph of this is y is equal to x square here. Now, if they ask that draw the graph of twice of f of x, we have seen it here that the values of x remain same, whereas y value is going to be changed with the coordinate a, y there. That means that every value of y in this case will be double of the previous value for the x there. So if it is 0, 0, it will remain 0, 0. But it is 1 here, which is 1 here, y value. So y value is now 2 f of x, so it will become 2 there. So one value is will come 2 for the function of value of y there. If it is 2 here, which is equal to 4, now twice of that 4 value is 8, so it will become 8 here. So same is with -1. So for -1 value is 1 there, which will be now equal to 2 there. And for -2, it is 4 there, which will become 8 there. And if we draw the graph between these values, so this is the graph of y equal to 2x squared here. Because this is 2 and x squared, f of x is x squared. So it is the graph of 2x squared here. So you have seen it is basically the sketching about what y-axis did. So now we can get the value of a equal to half of f of x. That is what? Half of x squared. So if this is the graph of y is equal to x squared, which is f of x, then this is the graph of y equal to half x squared. Again, it is the stretching due to x-axis or the y-axis here. So basically, this is the way that we are going to reflect it from this part here. Let's say y equal to minus f of x. If this one is the graph of y is equal to x squared, which is the f of x, then if we want to draw the graph of this, it is y equal to minus x squared. That means it is basically the reflection about x-axis here. So these are the 3 different cases which we are going to use for this property, that a f of x, that means x y will, if the point of the real, then the coordinates of the image there will be x and a y there. Now y is equal to f of ax. So according to the topic of transformation, it will be written like this, that if the point P is xy with the a factor there, the point image will become x over a and y. So you have seen in this case that the y coordinate is remaining same, whereas x coordinate is half of that value. Sorry, 1 over a of that value of x there. Suppose we have a point 1, 1, then the image of this point will be, if a is equal to, let's say 2, then the point 1, 1 will become 1 over 2 at 1. Or if the point is 4 and 2 there, the point will become as 2 and 2 there. If a is equal to half, then the point 1, 1 will become in the image there as 2, 1 over 1 over 2 and 1, which will be 2 and 1 there. If the point is 2 and 4 there, the point of image will be 2 divided by 1 by 2 and 4. So that thing will become point 4 and 4 there. If the point P is there, 3 and 6, then the point of image will be 3 divided by half and 6, which will be equal to 6 and 6 there. So you have seen it there that values of y are being changed and the values of x are retaining same values. Or x is the double of that value in this case here for a is equal to half. And if a is equal to 2, then it is the half of that value there. It is 1, it is going to be half. If it is 4, it is going to be 2 there. So it is basically this property is used for the topic of transformation for this y is equal to f of ax is the stretching about x-axis there. So this is the way that we are going to find it out in the solution of this problem, that whenever y is equal to f of ax, then x will be changed in the form of x over a and y is retaining its position there. Now, let's do it with the example that y is equal to f of x is equal to x square is the original graph. So this is the graph of y is equal to x square. For 0, 0, for it is 1 at this position. For 2, it is 4. For -2, it is also 4. For 3, it is, let's say that is 9. And for -3, it is also 9 here. So this is the graph of y is equal to f of x there. Now we have to draw the graph of y is equal to f of 2s, where a value is equal to 2 there. So from this graph, you can explain it by this method. It is the point original there is 0, 0. Now the point P dash will become 0, 0 there. So this point is 0, 0 there. If your point is 1 and 1, because this point is 1 and 1 there. Now for the image of this point is half and 1 because a is equal to 2. So you 1 divided by 2 is there, 1 over 2 and 1. So at this point, half, it is going to be same as 1 there. For this point 2 and 4, the image of this point will become 2, half is 1 and that is 4. So it is going to be, for this value of 1, it is going to be 4 there. Then for 3 and 9, this value will become 3 by 2 and 9. So this is the graph for the right side of the solution here. Same for P minus 1 and 1 will become P as minus 1, 2 and 1. This is minus 1 by 2. We write it as equal to 1. For P of minus 2 and 4, the point of image will be minus 1 and 4. For the point P is there as equal to minus 3 and 9, which point will be minus 3 by 2 and 9. So you have seen it, that it is the stretching of x-axis here, because x value is half of that value, which is a is 2, and y value is remaining same here. So it is basically the stretching about x-axis for the graph whenever it is changed in the form of y is equal to f of ax there. Let's solve another example here. Y is equal to f of x, and that is equal to square root of x. We know that the graph of this function is basically equal to this. For 0, 0 it is 0. For 1 it is equal to be 1. For 4 it is equal to be 2. For 9 it is equal to be 3. Now we have to draw the graph of this property that y is equal to f of half x. Now you have seen it there that a is equal to half of the square. So our point P, if it is 0, 0, then the point P dash will become 0, 0 there. So that point is retaining its position here. Then for the point 1 and 1, the point P dash will be equal to, because it is half of that value there. So that value is 1 over 1 by 2 and 1, which will become equal to 2 and 1 there. So if it is, let's say this position is 2 there, then it is going to be equal to 1 at this point. If P is equal to 2 and 4, 2 and 4 is exponent and the value of that one is 2, then the P dash will be equal to 4 over half and 2. So that means P dash will be equal to 8 and 2 there. So if P value is 3 and 9 for the original graph, 9 and 3, then P dash will be equal to 9 over 1 over 2 and 3. So that thing is equal to 18 and 3 here. So it should be, let's say here is 18, there is 3 here. So the graph of this will be like this. So it is basically the stretching due to x-axis with respect to the factor a is equal to half of that value. So this is the transformation topic, which is the first two parts we have done it there. Y equal to a f of x and y equal to f of ax. And now we will do the other parts in the second video of this topic for the transformation of this function into these properties by using the properties of stretching, one due to the x-axis and one due to the y-axis with respect to the property of a f of x and f of ax.